Section 2.7 Inequalities. In this section, we're going to take a look at inequalities. There are four basic inequalities in math. There are greater than, less than, greater than or equal to, and less than or equal to. There are some major differences between inequalities and equalities, so let's take a look at those really quick. One, okay, when multiplying or dividing an inequality by a negative number, we flip the direction of the inequality. So that's something we need to know. If you recall from earlier, if you have negative 2x is equal to 4, when we have an equality, the next step is to solve for x. We want x by itself, so you want to get rid of negative 2. So we divide both sides by negative 2, so we get x is equal to negative 2. And that's it. We don't need to do anything fancy. But with inequalities, when we're doing this, anytime we divide or multiply by a negative number, we have to flip the direction of the inequality. And I'll show you some examples of that in a second. The second major difference between the inequality and equality is this. The solution set, actually let me write it this way. The solution set of an inequality is usually infinite and should be written in interval notation. So that's another major difference between equality and inequality. The solution set, that means all possible solution. Usually with inequality is always infinite. Okay, and we write that solution in terms of an interval notation, and we'll talk about that in a second. Okay, I'll show you how to write things in interval notation. Okay. Alright, so those are the major differences between inequality and equality. We'll come back to those in a second. Let's talk about intervals. Intervals is just a compact way to represent a set of numbers. A set is just a collection of numbers, so interval is just a compact way to represent a set of numbers that are in sequence. Okay, set of numbers that are in sequence from low to high, from small to large, or whatever, however you want to call it. So let's take a look at some examples. Okay, so here are some examples of intervals. So let's say if I have an inequality like this, I have negative 2 is less than x is less than 3. So we are saying that x is any number between negative 2 and 3, not including negative 2 and 3. So if you look at your number line, if this is your number line, let's graph this on a number line. This is negative 2, there's some 0 in the middle, this is 3. So x is any number in between here, not including these numbers. So I'll put a hollow circle. That basically means we are not including the endpoints. So this is how you would represent an inequality graphically. But we want to represent it in terms of interval. What is interval? Collection of numbers, basically, because set is a collection of numbers in a sequence and in a row from low to high. So in this case, my interval would be written this way. It's all the numbers between negative 2 and 3 and not including negative 2 and 3. So we put parentheses. Parentheses basically means do not include the endpoint. Do not include the endpoint. That's what the parentheses represent. Okay, so this is an interval. It's not just the whole, it's not numbers just negative 1, 1 and 2. It's not just those numbers, it's all the numbers in between. There's infinite numbers in between here, because you can always have 0.5, 0.55, 0.555, 0.5555 and so on. So there's infinite numbers between negative 2 and 3. We always write the lower number first and the higher number. We use brackets, parentheses, to represent that. We use parentheses to indicate that the endpoints are not included. So all of these three things are exactly the same. They're just different ways to represent a sequence of numbers from small to large. Okay. Here's another example of an interval. I could have x's, and by the way, this interval, since neither endpoints are included, is called an open interval. We call this an open interval whenever neither endpoints are included of the interval. Here's an example of a closed one. So let's say if you have minus 3 is less than or equal to x is less than or equal to 5. So graphically, what does it mean? X is any number, a variable, any number between minus 3 and 5, including minus 3 and including 5. So if this is minus 3 on my number line, and this is 5 and 0 is in between here somewhere, it's all of these numbers, including 5. Okay, so in terms of an interval, we write the smaller number first, then the larger, and we use square brackets to indicate the endpoints are included. This basically means endpoints are included. Okay, so we call an interval where both the endpoints are included, we call that a closed interval. Okay, so it's the second type of interval you need to know. Then we also have other types of intervals. Let's take a look at those. Let's say if I have x is greater than or equal to 2. So what are we saying? X is any number bigger than 2. How many numbers are there that are bigger than 2? Infinite. So let's take a look at on a number line. If this is 0, 2 is here. X is any number bigger than that, so any number to the right of 2, because all the number to the right of 2 are greater than 2, including 2. Okay, so that is a graphical representation of that inequality. In terms of an interval, let's see how to write this. We start at the lower number first, smaller number 2, and then we go write the larger number. Well, x is any number bigger than 2, so this keeps going on and on and on. So how far do we go to the right? We go to infinite. So it's going to go to infinite. We're including 2, so we'll use the square bracket. But we cannot include infinite because we do not know what infinite is. So we'll have to use parentheses there, which means we are not including this endpoint. So out here we are including one endpoint and not including the other endpoint. So we call this a half-open interval. And if you want to be difficult, you can call it half-closed. It's the same thing. So these are some examples of intervals, which basically lets you represent a sequence of numbers from the smaller number to the larger number, okay, in a very compact form. You can use square brackets to indicate you're including the endpoints. You can use parentheses to indicate you're not including the endpoints, okay. Now that we know what intervals are, let's go ahead and take a look at how to solve inequalities. So we'll start with linear inequalities. Linear, again, if you remember, basically means degree 1. Okay, solving linear inequalities is the same as solving linear equations. So there's hardly any difference between the two. So let's take a look at an example. So let's say if I have something like this. If I have 3x plus 2 over 4 minus 5 minus 2x over 3 is less than or equal to x plus 4 over 6. So I want to solve this inequality. You can see this is an inequality. It's not an equality. I want to find a value of x for which the left hand side is less than or equal to the right hand side for which this inequality is true. Just like with equations, we want to find the value of x where two sides are equal, but out here we have an inequality to satisfy. So since we have fractions, if you had a linear equation with fractions, we would first try to get rid of those fractions. So let's do that. So to get rid of these fractions, we want to multiply each term by the common denominator. In this case, the common denominator is 12, and you can convince yourself of that. So you multiply each term by 12. Okay. So if you think about it, we are not doing anything different than what we did if it was an equality. Okay. So and that's the point I'm trying to get across. So in the first case, because this is over 1, we have multiplication. I can cancel. 4 goes into that once and 3 times. Remember, I cannot cancel like this here because of the addition in the middle. Okay, so please don't abuse that. Then we can distribute the 3. So we get 9x plus 6. Over here, 3 goes into this once and 4 times. We can distribute the negative 4. Don't forget the negative sign. We're distributing negative 4. Negative 4 times 5 is negative 20. Plus 8x is less than or equal to 6 goes into that once and 2 times. We can distribute the 2. We get 2x plus 8. So the key takeaway from this is now we don't have any fractions. So how would we have continued with this problem if it was an equation? We would have isolated all the x terms on one side. So let's do that. So we have 9x plus 8x. I'm going to move the 2x to the left, so you get negative 2x is less than or equal to, there's an 8 on the right, and then I'll move these two numbers to the right, so we get negative 6 plus 20. Okay, so let's start adding these. So we get 6x here plus 9x is 15x. Okay, is less than or equal to, out here we get 2 and 20 is 22. Okay, so now we want to divide both sides by 15 to solve for, to get x by itself. X is attached by multiplication, so we divide. So we get 15x over 15 is less than or equal to 22 over 15. So we get x is less than or equal to 22 over 15. So let's just think about it for a second on a number line. So let's say this is a number line. This is 0. This number here is 22 over 15, which is roughly 1 point something here. Do you guys follow? It's 1.4 something something something. Okay, so x is any number less than 22 over 15. What kind of numbers are less than this? All the numbers to the left of it. All of these numbers are less than that because as we go to the right, numbers get bigger. Okay, so x is any number to the left of that. So how many? So if you want to write an answer in terms of interval, we have to start with the smallest number. The smallest number is to the left. So how far left do we go? Negative infinite, because we keep going to the left until we know forever. And since we have negative numbers on the left, we'll say it's negative infinite. So we start with the smaller number, negative infinite. We use parentheses because we do not know what negative infinite is, so we can't really include it. And then on the right we have 22 over 15, the largest value. We use square brackets since it's less than or equal to. So here's the solution to that problem. So with inequalities, we always want to write answers in terms of intervals because we get infinite solutions. There's infinite numbers between minus infinite and 22 over 7. You can always check your answers just like we did with equations by picking any number in here to see in this interval to see if it satisfies your equation that was given to us. Since 0 is in that interval, let's pick 0 to see if it works. Okay, so if x is 0, this is gone, this is gone, this is gone. So you get 2 over 4, which is 1/2, minus 5 over 3 is less than or equal to 2 over 3. Because this is gone, we get 4/3, which is 2/3. On the left here, we'll have to find the common denominator and add these two numbers, which is 6, the common denominator. So you get 3 minus 10, so you get negative 7 over 6 is less than or equal to 2 over 3. And that's true because negative numbers are less than positive, so that's true, so that works. And you can keep trying different values since we have infinite values to double check your work. So if you really take a step back and look at this, we didn't do anything different than if it was an equation. We just basically, you know, followed the same steps that we did for equations. Alright? The only thing we would have done was if this was a negative 15 here, x, when I divide both sides by negative 15, we would have flipped this inequality, the direction of that. Okay, so let me show you an example where we do that. Let's say if I have 3x minus 4 times excuse me, 5 minus 2x plus 2x is less than or equal to x plus 7. So let's take a look at this. Okay. Actually, let's do x plus 10. Alright. This is an inequality. I want to solve this inequality for x. Since if it was an equality, our first goal would be to get rid of the parentheses, right? So we're going to do the same thing. We're going to distribute here. So we get 3x minus 20 minus 8x is less than or equal to x plus 10. Okay. So I want to solve for x. I want all the x terms on one side. They stay there. This goes there. So we get 3x minus 8x minus x is less than or equal to 10 plus 20. So on the left we get negative 6x is less than or equal to 30. So now we're going to divide both sides by negative 6. So we have to flip this inequality. So you have to remember to do that. So x is greater than or equal to 30 over negative 6. So we change the direction of the inequality here from here to here. So keep that in mind. And this can be reduced further. So we get x is greater than or equal to negative 5. So that's my solution to the inequality. We don't want to leave our answer like this. We always want to write our answer in interval notation. So if you just graph it, you can see it better. This is the number line. X is any number bigger than negative 3 including bigger than negative 5 including negative 5. So this is negative 5. There's 0 here somewhere on the number line. X is any number bigger than that. All the numbers bigger than that are to the right, all the way up to infinite here. Okay, including negative 5, so I'll put a solid circle. So in terms of an interval, we start with the smallest number here, minus 5 to the largest, including that, not including that. There's the answer to that problem. Okay, so I've done a couple problems that are linear inequalities. Let me do one more. This is also a linear inequality, but we also call it a compound inequality. The idea is still exactly the same as what I did in the last two problems. So let me show you what I mean by that. A compound inequality is where you have two inequalities in the same problem. So I could have something like this. Minus 3 is less than 2x plus 5 is less than or equal to 17. Okay. So now I want to solve this inequality. So let's just, for the sake of argument, let's see what would happen if I didn't have this. do I know how to solve this? If this was an equation, I would have moved the 5 over and then divide by 2. Now, because I have 17 here, how would I have done this? Well, how would I have solved this inequality? I would have moved the 5 over and divide by 2. So you can see in both cases we are doing exactly the same steps. So to solve this compound inequality, we have to do the same steps twice. So we can do them concurrently. So let's do that. So the first goal is whenever we're solving for x, we want to isolate it. So I want to get rid of all the stuff around it. So let's start by 5. 5 is attached by addition, so you move it. You move the 5 on either side because we always move the numbers around. So you get negative 3 minus 5 is less than 2x is less than 17 minus 5. So you get negative 8 is less than 2x is less than or equal to 12. Then we're going to divide everything by 2 because that's what we would do on one side here, and we also have to do it on this side since we have two inequalities. If this was a negative 2, then I would flip all the directions of both the inequalities. So in this case we get negative 8 divided by 2 is less than x is less than or equal to 12 divided by 2. So we get negative 4 is less than x is less than or equal to 6. So x is any number between negative 4 and 6. If you look at your number line again, x is any number between negative 4 and 6. There's 0 in here somewhere. So x is any of these numbers. It includes 6 but does not include negative 4. So in terms of an interval, we start with the smaller number, go to the larger number. Since it includes 6, we put square brackets and parentheses since it doesn't include negative 4. There's your solution. So the compound inequalities are pretty much the same as regular inequalities. You just have to basically do everything twice and the same problem concurrently. Okay? Now the next topic that we're going to take a look at is a little bit different. Solving quadratic let me reword it. Let's do it this way. We want to solve degree 2 or higher inequalities and rational inequalities. If you remember, rational is a fancy word for fractions, where we have a polynomial in the numerator and a polynomial in the denominator. That's what rational is. So we want to solve these. So these are going to be a little bit different than what we did with rational equations and quadratic equations and so on. So we're going to deviate now. When the inequality has degree 1, like the ones I just did, if you notice the degree is 1 here, the degree is 1. With these inequalities, we solve them exactly the same way as we solve linear equations. But when we get into this, we cannot do them the same way. There's a special method to do these, and you have to follow this method because there's no shortcuts around this. Okay, so just bear that in mind. Make sure you recognize that we have this case, and if we do, then we need to use this method that I'm going to talk about. So the first thing we want to do is we want to make sure there is a 0 on the right hand side. Actually, let's write it this way. We want to move everything to the left hand side. The second step is we want to factor or simplify the left hand side. The next step is we want to find the zeros of the factors. And then the last thing we want to do is we want to draw a sign chart. Now let me stress one more time. Over the years, of teaching algebra for countless number of years, I've found out that students will always forget to use the specific method for these types of inequalities, degree 2 or higher or rational. And as soon as you do not use this method, you're not going to get the right answer. So it doesn't matter what you do beyond that point. So if you're going to go down the wrong path, you're going to get no points. So it's very vital that when you do your homework and when you also take the test, you always remember if you have degree 2 or higher or rational inequalities, there's a very specific way of solving those. And these are the steps we use to solve those. There's no shortcuts or no other way around it. Okay? So let me do an example of both types. So let's say if I have this, if I have x cubed minus 3x squared is less than or equal to 10x. Okay, you can see this is an inequality clearly, and it's degree 2 or higher because it's actually degree 3. So what do we want to do? What does it say? We want to move everything to one side, to the left hand side. So we get x cubed minus 3x squared minus 10x is less than or equal to 0. Okay, then we want to simplify or factor the left hand side. Okay, so let's factor here. Since there's an x common in all the terms, let's take it out. So we get x squared minus 3x minus 10. When we factor, we always look for the greatest common factor first, right? That's what this was. Then we look at the number of terms. If you have 3 terms with degree 2, we use the AC method. And you can go on the side and factor this, or you can just factor it right here. Okay, since we're using the AC method, I want two numbers. When I multiply, I get negative 10, and when I add, I get negative 3. The two numbers are x minus 5 and x plus 2. So we factored them. Then we want to find the zeros of the factor. What does that mean? We want to basically find when each of these factors will be 0. When will x be 0? When it is 0 itself. So the zeros are 0. When will x be 0 here? If it's 5. When will x, what value of x will make this factor 0? When x is negative 2. So those are my zeros of that factor. Because what the zeros do is each of these factors is going to change sign at that 0. Like for example, let's take a look at this x minus 5. Okay, it is 0 at 5, correct? So if I pick any number to the left here, this factor x minus 5 will always be negative. And you can test that. Pick any number to the left of 5. Let's say I picked 2. If x is 2, we get what? 2 minus 5, we get negative 3. It's negative. Okay. On the other hand, let's say if I pick negative 10, which is to the left of 5, you get negative 10 minus 5. That gives you negative 15. It's still negative. So what the zeros do is they give you an exact split where this factor is going to change signs. To the left it's negative, and to the right it's going to be what now? If you pick any number to the right of 5, this is always going to be positive. Let's say if you pick 6, 6 minus 5 is 1. If you pick 20, 20 minus 5 is 15. But you can see it's always positive. Okay, so the zeros of each factor are the points where that particular factor changes signs from negative to positive. So just remember that. That's going to be very vital. Okay, because each of these factors is going to change signs at different places on the number line. Okay, like for example, this one changes signs at negative 2. So if this is negative 2 here, this factor is going to be positive to the right, negative to the left. Similarly, this factor will change signs when x is 0, and so on. So to be able to take into account the change in sign for each of these factors, the best thing to do is draw a little sign chart. So let's do that. This is your number line, and on the left here we're just going to put all our factors that we have. We have x, x minus 5, and x plus 2. Okay, so we plot our zeros on the bottom. When are these zeros? When x is 0 itself, when x is 5, when x is negative 2, because each of these factors has zeros at these values. Okay, so now what did I tell you earlier? for each 0, basically what does it do? It changes this, it gives you the point where the factor changes signs from negative to positive. So let's start with this factor x. The 0 for this factor is right here. So let's see if I had this extended. So to the left of this 0, this factor is going to be negative, and to the right is going to be positive. Okay, let me actually go ahead. Yeah, positive. This factor is 0 when x is 5. So this is a 0 for this factor if you extend it. To the left of this factor 5, this is always going to be negative. To the right is going to be positive. So let me go ahead and write it this way. Okay. This is 0 when x is negative 2. So this is my 0 for this factor. And to the left numbers are negative. To the right they're going to be positive. Okay. So you saw me fill this out, so I'm going to erase this and fill it out again, just a little bit quicker this time, just to show you, so it's not so messy. So here's my number line, here are my factors. I plot the smaller one first, 0, and the larger one, and then I'm just going to draw a dotted line and extend these. So you can imagine these are your boundaries for each of the factors. The boundary for this factor is x is 0. Okay, so this is where this factor changes sign. It changes sign from negative to positive. So to the left of 0, so this is my 0 for this factor. To the left numbers are negative. To the right they're positive. And you can see that on a number line. If this is 0, to the left numbers are negative, and to the right they are positive. Okay. X minus 5 is 0 right here when x is 5. So to the left numbers are negative and they're positive. And I showed you if I had picked any number to the left of 5, x minus 5 would be negative. If I had picked any number to the right of 5, x minus 5 would be positive. Similarly, x plus 2 is 0 when x is negative 2. To the left of that numbers are negative, to the right they are positive. And you can convince yourself. Let's try it. Let's pick any number to the left of negative 2. So we can pick negative 10. So if x is negative 10, what happens to this? You have x plus 2. So we have negative 10 plus 2, we get negative 8. So you can see this is negative. On the other hand, if I pick any x to the right of negative 2, it's always going to be positive. So if x is 0, this will be 0. Okay, if x is 0, we get 0 plus 2, which is 2, which is a positive number. Okay, so the zeros are very important because they give you that boundary where the factor changes sign from negative to positive. Now what are we doing? I'm multiplying these three factors, right? So I'm going to multiply the signs each of these factors contribute on the number line. So you get negative times negative is positive, positive times negative is negative. Out here we get positive, negative times negative is positive times positive, positive times negative is negative, negative times positive is negative, and this gives me positive. So what this tells you is that to the left of negative 2, if I were to multiply all of these factors, I would always get a negative answer. Between negative 2 and 0, if I were to multiply all of these factors, I would always get a positive answer, and so on. Okay. So now what we'll be looking for, if you go back to the last inequality, not the first one but the last one, we wanted what? We wanted this left hand side, all our factors, to be less than or equal to 0. When we say something is less than 0, we mean it is negative. So we were looking for negative products. So the negative products occur here. You can see it's negative, and it's negative here in between. So if I pick x in this yellow region, this product will always be less than or equal to 0, or it will be negative. Okay, so my solution is what? How far left do I go? Minus infinite. So you start with the smallest value, go to the largest. Okay, because it's less than or equal to, we're going to include the endpoint. Okay, And then we're going to combine it with a symbol called u. This is a union symbol, which basically tells you the x can be in this, or it stands for the word or, in this interval, which is 0, 5. So there's your solution to that problem. Okay, x can be in this yellow interval or this one. Let's check the answer in both. Okay, so let's pick a number to the left of -2. So let's say I pick -3. That's in this interval, correct? So let's test it. So let's plug it in here. We want the left hand side to be less than or equal to the right hand side. So let's calculate the left hand side. If x is -3, -3 cubed is -27, minus -3 cubed is -27 times 3 is, -3 squared is 9, 9 times 3 is 27, so you get -54. Out here we get 10 times -3 is -30. Is -30 less than or equal to -54? Okay, no. So what did we do wrong here? Just make sure we didn't make a mistake. I'm sorry, -54 is less than -30. That's a true statement. Okay, I said it the wrong way. So that works. Okay, let's pick a number in between here that doesn't work. So -1 is in between there. So let's try what happens if x is -1. -1 cubed is -1, minus -1 squared is 1. 1 times 3 is 3. So we get -4. Out here on this side we get 10 times -1 is -10. Is -10 greater than -4? No, so that doesn't work, so that's good. If I pick any number in here, it should work now, 0 to 5. So let's pick 2. 2 is in that interval. So 2 cubed is 8, minus 2 squared is 4. 4 times 3 is 12, so you get -4 is less than 10 times 2 is 20. Is 20 greater than -4? Yes, it is. So you can see once we get an answer, we can quickly check an answer, and that works over there. So, and there's really no other way to do these problems. So as soon as you recognize that you have an inequality that's degree 2 or higher, you have to do it this way. So please remember that. Let me do an example of rational inequality. So let's say if I have this 3x plus 1 is less than x minus 1, which is greater than or equal to 5. Okay, so let's take a look at this. This is an inequality. It's rational because it has fractions. Now students are always tempted, because if I had given you this problem, the first thing you would do is you would recognize that I want to solve this for x, I want to get rid of the fraction. Two fractions are equal, so we can cross multiply and I can do it quick. Even though I tell students not to do this, I keep saying that for rational inequalities there's a specific method. It's the same method that I used for degree 2 or higher inequalities. Students will still continue to do it this way, so please don't do that. The reason why we cannot do that is because if I cross multiply, I'm multiplying something that contains a variable here. Now, if x was, for example, in this example, if x was 5, then cross multiplying is not a big deal because this number is positive, because if x was 5, you get 5 minus 1 is 4. But on the other hand, if x was minus 2, then this number would be negative, because -2 minus 1 is -3. And if you multiply by -3 here, we would have to flip the direction of the inequality, won't we? So because we do not know what x is yet, we cannot assume it's positive or negative and just cross multiply, because depending upon what that quantity is in the denominator, positive or negative, that'll affect the inequality. It'll flip it if it's negative, and if it's positive, it'll leave it alone. Because of that, we really cannot cross multiply here at all. So what we want to do is, okay, we want to move the 5 to the opposite side and get the 0 here, because that's what our goal is always, to move all the terms to the left hand side and then simplify and factor the left hand side. So let's do that. So we get 3x plus 1 over x minus 1 minus 5 is greater than or equal to 0. Now this is over 1. I cannot factor anything here, but I can simplify. I can add these guys up, right? Because anytime you see fractions, your first reaction should be to add them. We're not trying to get rid of the fraction, so bear that in mind, okay? So the common denominator here is x minus 1. So I'm going to multiply this by x minus 1 and this by x minus 1 to make them the same denominators. So we get 3x plus 1 over x minus 1 minus 5x minus 1 times x minus 1. I'm just writing that step out for you. Now since the two denominators are the same, we can write them as 1, and we can distribute the negative 5. Remember, you're distributing the negative 5. Minus 5x plus 5 is greater than or equal to 0. Okay, now let's collect the terms here. So what do we get? We get 3x minus 5x is negative 2x. And then 1 plus 5 is 6, divided by x minus 1 is greater than or equal to 0. So now what are we going to do? Well, one of the things I tried to teach you in the last section on factoring is that we always want the leading coefficient of our polynomials to be positive. Excuse me. And if we don't fix that here, we're actually going to get the wrong answer. So the best way to fix that here is, because I want this to be positive, I can multiply both sides by a negative 1. And if I do that, I'll have to flip the inequalities, because anytime you multiply or divide an inequality by a negative, you flip the direction of that inequality. So I'm also going to do one better. Since there's a 2 common on the top there, I'm actually going to divide both sides by negative 2. We can do that. We've talked about that. If you have a common factor on both sides, it's always good to divide it out so that your numbers become smaller. So I'm going to divide negative 2x by negative 2, so I get x. And positive 6 by negative 2, I get negative 3. The denominator stays the same. And now the inequality will flip here because we're dividing by a negative number. So this will become greater than or, less than or equal to. And 0 divided by negative 2 is still 0. So there's your inequality. Now, once we are done with that, what do we want to do? We simplified that. Okay, now we want to find the zeros of the factors. What's left? So let's find the zeros, because those zeros are the points on the number line where each factor changes signs from negative to positive. So this factor is 0 when x is what? 3. This factor is 0 when x is 1. So those are my two zeros. So we can quickly draw a number chart here, sign chart that we talked about a minute ago. You put the smaller number 0 first, which is 1, then the larger 0. You extend them. You put your factors on the outside. So you get x minus 3 and x minus 1. So now let's take a look at it. X minus 3 is 0 when x is 3. You can see that 3 minus 3 is 0. So this is my 0 for this factor, because this is the boundary where this factor changes signs from negative to positive. We can test it. If I pick any number to the left of 3 here, this factor will always be negative. If I pick 0, 0 minus 3 is negative 3. If I picked 1, 1 minus 3 is negative 2, and so on. On the other hand, if I pick any number to the right of 3, this factor will always be positive. 4 minus 3, 5 minus 3, 10.5 minus 3, and so on. So you can see that the 0 for this factor is this, and to the left numbers are negative, to the right they're going to be positive, just like on a number line. On a number line, to the left of 0 numbers are negative, and to the right they are positive. This factor x minus 1 is 0 when x is 1. So here's my 0 for this factor. Okay, if I pick any number to the left of 1, this factor will always be negative. If I pick any number to the right of 1, this factor will always be positive. And again, you can convince yourself of that. What are we doing to these two factors? We're dividing them. So we want to divide the sign that they each contributes. So negative divided by negative is a positive. Negative divided by positive is a negative. Positive divided by positive is positive. So what does this tell us? If I pick any x in this region, I'm sorry, before I do that I should look at the inequality. We wanted this left hand side here to be less than or equal to 0. What does it mean for something to be less than or equal to 0? It means it has to be negative. It has to be less than 0. Remember, I did not pay attention to this inequality. You always look at the last inequality to figure out the sign. So I want the left hand side to be less than 0. I want it to be negative. So I want this division, this quotient, to be negative. So I'm looking, the answer is going to be in here, because this is where that quotient is negative. If I divide this by this, I'm going to divide negative by positive in here, so I'm going to get a negative. So if x is any number between 1 and 3, this is going to be true, and if that is true, all of these steps on the top are true, and that would imply this is true. Okay, so let's test this and do it. So first of all, before I do that, let's write it as an interval. You write your smaller number first, then your larger number. Since it's less than or equal to, we have to include the endpoints. So if I do that, okay, all the numbers between 1 and 3, including 1 and 3. But before I go any further, I do want to point out, you cannot really include, even though it's less than or equal to, we cannot include 1, because if x is 1, then you replace this x with 1, you get 1 minus 1 is 0. So you'll get division by 0. So even though it's less than or equal to, this still has to be a parenthesis, because x cannot be 1. So there's your solution. Okay, let's test this. Let's pick a number in here to see if it works. Let's pick 2. So what happens if x is 2? On the left we get 3 times 2 is 6, 6 plus 1 is 7, and then 2 minus 1 is 1. Is 7 greater than or equal to 5? Sure it is. So you can see it works perfectly fine. Okay, so that's how you solve a rational inequality. I've done 2 examples. You just have to sit and follow these 2 examples when you do your homework. Keep the video up in front of you and just follow them till you understand these problems completely, because these problems have to be done this way, so there's no other shortcuts for them or anything like that. So try to follow these examples when you're doing rational inequality or degree 2 or higher inequality.